Hello and welcome everyone to this video on System Thinking course. Today myself, Parthasarathi Seshadri, and my batchmates are here to join this discussion on the relevance and benefits of systems engineering. So, to start with the relevance of system engineering basically refers to the engineering or the re-engineering. So, the term is very important. It refers to the engineering or re-engineering of any commercial or non-commercial systems or systems that are large or small or simple or complex. So basically, we can apply this system engineering to any type of system, let it be complex or a simple one, let it be large or small or any type of system. We can apply system engineering, and the purpose of system engineering is to engineer or re-engineer the existing system or engineer a new system to solve the problem. So it is applicable to the software or hardware based systems that can include products which are based on hardware, software, firmware, personal facility, data, materials, or any other kind of services, techniques or processes. So it is open to all the type of systems. And the main aim is to re-engineering an existing product. So by re-engineering an existing product, we can improve the performance of the product and can solve the problem that is being faced at present with the existing system, or we can find a new solution, that is a new system to the existing problem. So that is being given below that it can be either a new system, or even though if it is tough to imagine a system which is like conceptual in nature that can solve the problem, we can also do that. We can conceptualize the design, and then we can proceed to solve and design the system. So this is what is basically system engineering. So let's proceed further. So now, coming to the process of re-engineering, the primary step is to first develop the vision and objectives. So any problem is to be clearly stated. So what is the objective that we are going to achieve by doing the re-engineering? What is the problem with the existing product? What is our objective? What is our vision? What are we going to what are we going to plan to solve? So that is very important in order to step ahead in with the re-engineering process. So only if our objective is clearly defined, we can proceed with the problem and we can find the alternatives and solution to the problem. So next comes understanding the existing processes. Since the problem is re-engineering, we should understand the existing process clearly so that we can improvise or we can work upon the same to for the improvement or the betterment of the existing product. So the next step is followed by identifying the processes for the redesign. So what are the stages, what are the processes, what are the primary steps that we need to follow to redesign the same product, because the same product might have come through steps of design previously. So that steps need to be followed in order to accomplish the new design with the desired objectives and vision. And finally, we need to implement the sequence of steps. So we need to implement the new process into the real time, so it should solve the real time problem actually. So implementing the concept into the real time is a very important statement, so which is the next step. And this is followed by we have to make new processes operational. So the process which we have proposed by re-engineering should be operational. That is, it should function properly and it should actually satisfy the objective or the stakeholder requirement. And once it is able to serve the purpose, we can evaluate the feasibility of the new process. So whether the new process is really helpful to the stakeholder, and there are many criteria to evaluate such new concepts of re-engineering, and we can evaluate it based on cost, we can evaluate it based on maintenance, some of the basic criteria, and whether the new technique proposed is feasible for a long time run, or it is feasible economically. So that is the evaluation scheme basically. And if it fails to meet some of the evaluation criteria, we can also go for some continuous improvements techniques that can further enhance the development of the current system. So this is basically the entire re-engineering process. So now let me give an example of a re-engineering problem that is applied to the real life situation. So we have seen many vendors who have set up stalls in the roadside with the help of patio umbrellas. But the re-engineering phase in this problem is that these vendors require lights when the environment is dark. That is, during the day they can set up the stalls easily, but when it is night, they need lights and they also need shade from the sun. And if it rains, they also need to protect their stalls from that. So, if we talk about the scenario of Indian markets, it revealed that about 80% of the vendors who set up small stalls or any small scale business face a major capital challenge of investment in energy. So they need to carry separate battery for setting lights in their stalls during the night, and these are some kind of challenges that they face. But the re-engineering phase to this problem is that if we can make a solar powered patio umbrella system, it can really solve this problem. So we can harness the solar energy, and that solar energy can be directly used to power the lights or the small power charging port devices. And if it is implemented in real time, these people can easily set up the stalls in no time, and it would be really efficient. Instead of carrying separate battery, instead of carrying the lights and the emergency lamps, the battery operated ones, if we can make a system that can really solve this problem, then it would be a really helpful one. So this is an example, a typical example of what re-engineering is actually going to bring, and what is the change it is going to drive from the current situation to a better situation.
Hello everyone, myself Hemadashri. Here I am going to explain the relevance of system engineering. System engineering can be applied to all kinds of systems where we have to infuse our thought process. Thoughtless application of system engineering can increase cost, complexity and schedule without any reduction in size. We must tailor system engineering activities so that they add values and reduce risk. We must be cognizant of project size, complexity, and risk. A research shows that the effective use of system engineering can save 10 to 20% of the project budget. Customers and contractors are the two important parties. Customers use the system engineering to give their requirements and monitor contractors' progress and the risk, while the contractors use system engineering to develop effective process for the design, development and the test of systems. Both the parties, that is customers and contractors, are looking forward to produce the quality system. From this, we came to know that the system engineering is relevant to both the customer and the contractors. Here I am going to explain how the system engineering is relevant to both the customers and the contractors. In order to explain this, I am taking the solar for patio umbrella system as an example. This is our project. Here our customers are street vendors and their requirements are they need a small scale which include the shade, lighting during night, a charging port for the entire day. We the system engineer might look forward to meet the requirements of our customer by considering the following factors which may include battery backup required, size of the patio umbrella system, rating of the electrical use, low cost and simple design, and the portability of the system. This is how the system engineering is relevant to both the customers and the contractors. If the customers fail to give the requirements correctly, then the system engineer can't able to design the system effectively. In this slide, we can see the benefits of system engineering. We can get a large number of benefits from system engineering if we apply all the concepts of system engineering properly. The life cycle cost can be reduced by system engineering if we apply all the concepts of system engineering while designing a system. There will also be the reduction of time schedule in order to complete the system, and the reduction in technical risk can also be possible by system engineering. We can improve the quality of the system also. Here we are going to see the life cycle cost saving. Savings over the entire life cycle are possible due to the system engineering focus on the entire life cycle. Some argue that system engineering adds too much complexity, cost and time to the acquisition phase. This may be true to an extent, but the yearly additional effort should be thought of an investment that will be return time and again throughout the life of the system.
Let we look into the relevance of the system engineering by getting the requirement right early and then monitoring their inclusion into the design. We can reduce the potential for cost and the time consumed. This was being explained in the figure impact of system engineering, which also include a system failures and cost overruns and problems which direct to the result to the poor requirements, which cannot be rectified by good design also. To overcome from this, our projects have been collected the requirement from the user. In fact, the curve in the figure has been labeled as a easy a blue color line with which the changes can be made throughout the system life cycle. Additionally, as illustrated in the second curve, the red color curve in the figure, the greatest impact of requirement engineering comes at a time when the cost of the implementation changes is the lowest. Next, we move on to the reduction technical risk. System engineering has a lot of tools mainly aimed at risk reduction associated with the development of the system. If there are more feasible alternatives, system engineering also forced to select the best solution. Through system engineering, design requirements can be tracked back to the original user requirements and conflict the user requirements can be identified. Technical risk is monitored and assessed continuously, ensure that risk in a time and manner. Finally, we came to the quality system. In this, we discuss as system engineering leads to a product quality. The quality refers fitness for purpose or the ability of the system. In our system, the specified requirement accurately reflect the business and stakeholder needs, which gives the best result. Next, system engineering framework and process. In this, we had discussed about the design of our project and what are the activity and management we have done. I will give some general layout of this framework. System engineering tools integrate the management and the process. Management is nothing but controlling the process. The process is called doing or proceeding our work relevant to our line. It includes the conceptual design task, preliminary design task, and detailed design task, product task, and utilization related task.
Now, coming to the framework of the system engineering process, so we mainly focus or concentrate on the main aim, that is the objective or the vision of the current problem. So if the problem objective is very clear, our foundation is very clear. We can easily move upon to the next stages, what is to be done to actually solve or redesign the system to solve the problem. So we basically emphasize on the activities that we emphasize the activities keeping into mind the main aim of the current project. So that is where the framework strength of the system engineering lies. So let us take a small example. We come back to the earlier example that we discussed previously. That is to develop a low-cost solar-powered umbrella, that is a patio umbrella system that meets the basic requirements for setting up a stall at a specific location, and it should withstand through an entire day with sufficient backup. So earlier there was a patio umbrella, but however this umbrella can be redesigned with the necessary backup, battery backup, and all the kind of facilities and the electrics embedding into it. So doing so would be a really efficient product for the street vendors. So that is what the framework we need to develop, but we are keeping into mind the aim, that is the objective, the problem that we're going to solve, that is going to meet the objectives of the stakeholder, that is the street vendors. Coming back to our example, the early phase activities that is associated with our design problem, that is solar powered patio umbrella system, can be first to identify the stakeholder requirements, because only if the objective is clear we can proceed further, and at every stage we need to keep the objectives and the aim in our mind and perform the design process sequentially. And we need to look back to the existing drawbacks, that is the research to the current problem. Then comes our conceptual design, followed by the pre-analysis through MATLAB simulation. So here we have considered the pre-analysis, that is testing of the propose the design before implementing into real-time hardware through MATLAB simulation, because a simulation will give an estimate whether that it will withstand the real-time conditions on an approximate basis so that it can be applied to the real world. And finally, next comes the project estimate, which is an important factor. The main phase will be the budget planning, and then we can build the prototype based on our estimates and based on our design. If these steps are clear, then building the prototype will not be difficult actually. So if our design is clear and we have the allocated budget and we have looked into the existing research and the requirements, so if the requirements is clear, then our design will be clear, and if the design is clear, then we can test our design, and if the tests are passed, we can allocate the budget and build the actual prototype. So this is how the process works.
System engineering framework, which is nothing but how we concentrate on the intent and the main aim of the each application of the foundation process, which defines how we frame a work and how we get into the task and how we complete it. It says completely about how we are going to done the programming. Likewise, the system engineering management oversees the system engineering process, and it plays a monitoring, directing, controlling, and reports roles, including important functions such as technical reviews and audits, test and evaluation, technical risk management, configuration management, specifications, standards, integration management. Management is critical and is certainly placed in the framework, uh, which uh, which is shortly defined as how the system engineering framework is going to be done. System engineering processes and tasks are divided into the life cycle stages within which they typically occur. Many tools exist to assess the system engineering process and management. These tools ranges from techniques and methods through to system engineering standards. Here we describe the most popular tools and standards without repeating the information contained elsewhere in the standards and documentations. The generic processes tools such as requirement breakdown structure (RBS), functional flow block diagram (FFBD), work breakdown structure (WBS), trade-off analysis, and prototyping and simulation as an example of tool that may be applied to the system engineering process effect. Also describe the system engineering management tools of standards and capability maturity of the models. There are many disciplines, both technical and non-technical, related to the system engineering. Examples such as project management, logistic management, quality assurance, requirement engineering, hardware engineering, and software engineering. These disciplines takes up a different position within our framework. In system engineering process, several tools and techniques can be employed. Commenced with the perceived need for the system. Development of a formal requirement, what the system is do, how well, within what constraints, which interfaces. Analyze the continuous throughout the acquisition phase, but later it used to asset with the determination, assemblers, and the components of physical design.
So at this point, we have come across the system engineering process. So what we understand is that it is basically the synthesis, that is the design and creation function. So design and creation form the basis of system engineering. Going to design, we are going to create something new that is going to meet the objective of the stakeholder and overcome the problems in the existing situation. So it is going to tell us how our system is going to perform, how well it will do, and what are the synthesis purposes to achieve it. So this is the well recognized role of the professional engineers. They are supposed to analyze, do critical thinking processes in order to meet such challenges. So this is limited in the early stages of decisions, that is relating to the overall technical approach. So the early stage, it is a conceptual phase. We are going to just discuss on the broad physical architecture, what is going to actually, what is the basic functionality, what is the main aim, and then we go in deep to solve the design process and going into too technical terms. So later the synthesis will become very detailed. So a small overview of the process. So let's go further. So now, summarizing the entire system engineering process, the first stage is evaluating the existing system. That is, we need to look into the drawbacks of the existing system, understand what is the problem faced, and we need to fix upon the objectives or the requirements of the customers that we are going to meet with the system engineering process. So once this evaluation is performed, we'll be clear on upon the objectives or the problem that we are going to meet through the new design or by re-engineering the existing system. And with this, we need to investigate on the trade-offs between the requirements and the design. So this is because at some times in the design, we may not be able to meet the requirement completely, but we may be able to meet it partially. So there might be some technical difficulties. So we need to investigate those kind of trade-offs between the requirements and this design, such as if the cost increases, then the output it's a simple example, like if we increase the cost, if we increase the investment, then we'll have better returns. So we need to make a proper trade-off between the requirements and the design. And we should also consider the alternatives, because once some kind of problems arise or technical difficulties arise with the current design or the requirements, we need to also consider the alternatives that can equivalently solve the problem, and we should evaluate the best alternatives among the possible solutions. And once this evaluation is performed, so evaluation is basically based on many criteria, such as the some of the basic criteria include maintenance cost and how difficult is the process and what is the investment in the project. So these are some basic valuation criteria, and upon confirmation of the design, we can proceed ahead to make the prototype or the hardware design that can actually solve the process. So with this example, so evaluation will result in some kind of discrepancies or some kind of problems that further need to be still addressed. So this falls into the scope of the further development after re-engineering the product through the system engineering process. And once everything is set, finally comes the documentation of the entire work based on the reviews and the evaluation of the design. And if everything is done, then our entire system is ready and set, and it is re-engineered to solve the existing problems. And with this, we'll be ultimately able to solve a societal problem that is being faced in current with a new engineering solution, that is system engineering solution, with the entire new system or by re-engineering the existing system. So I hope everything is clear till now. So I would like to conclude this discussion at this point. Thank you so much. See you soon with your new innovative system.